You are watching the 3.8 lesson video on arithmetic sequences. So you probably remember, or maybe you don't, from the past when we talked about recursive patterns. So patterns that build on the step before. This is one of those times that we are going to revisit one of these types of sequences or recursive patterns this year. So Exercise 1, let's just get right into the notes. Consider the sequence below, and it says if we represent this sequence with the letter A, then do the following. All right, so they want this to be A. All right, maybe I want to use a table to set up maybe? Okay, so I have all of these values. There's a value. Here's another value. There's another value. And so on and so forth. So let's make a table of all of these. And it looks like they are telling us to label this part here. Let's pick a different color. This is A, or maybe let's say it's A sub n, and this is then n. And n is always the term number. So 4 would be my first term, 8 would be my second term, 16 would be my third, fourth, fifth, sixth, seventh, and so on and so forth. All right, so exercise 1 wants us to, in part A, find A of 3, which that just means when n is 3, what is my output? And that looks like it's 16. All right, A of 1. So my first term is 4 plus my seventh term, which is 256. So 4 plus 256 is 260. Then A sub 2, so I input 2 and I get out an 8. Remember, this is just asking the same thing that A, B, and C were asking. It's just written in a different way. So that's just a quick little recap of how sequences work. Let's step this up a little bit further. So exercise 2 wants us to consider a sequence given the following information. They told us this here, B sub 1 is 7. All right, so what does that mean? So the first term is 7. So term number 1 is 7. And then they told us B sub I, which is the same thing as, oh, okay, now I'm seeing it. This is a before, now, next rule because I have this B sub I minus 1. So here's my now, here's my before. So my now will equal the before plus 4. So B says write out the rule for the first terms and evaluate each one of them. All right, so what does this mean? Write out the rule for the first 4 terms and evaluate each one of them. Well, we've used the before, now, next rule, so let's, I think, didn't we always just make a table? Didn't that help us? So let's just do that. In this case, it looks like our term is I. We're putting in I, and we're getting out like B sub I. It looks weird, but let's just go for it. They told us what our first term was, and they want us to do this with the first 4 terms, it looks like. So they told us that term number 1 is 7. Well, thank goodness, because don't we always need a starting point? And we only have to do the first 4 terms. So 1, 2, 3, 4. Okay, so how do I get to the next term? Well, this is where the before, now, next rule comes into play. So the now, so my now is equal to the before plus 4. So we're just adding 4. So this is 7 plus 4, which is 11. Repeat. But instead of using 7, now we're going to use 11 plus 4, which is 15. And instead of using 11 or 7, we'll use 15 because we always build on the step before. And 15 plus 4 is 19. So to interpret this table, the first term is 7, the second term is 11, the third term is 15, the fourth term is 19. I could keep doing this over and over and over and over and over again if I wanted to. But notice how we're adding 4 every single time. So this appears to be some type of a linear pattern, probably the reason why we're looking at this in the linear functions unit. All right, this brings us to exercise 3. If the pattern of blocks continues, what formulas could be used to determine the number of blocks in the nth term? Okay, this is a little weird. They haven't set anything up in a table for me, but I think I'm immediately going to put my stuff in a table because tables have been very helpful for us up till this point, and I don't see why we shouldn't. So we usually look at the term. So what term is it? And we're looking at the what? The number of blocks. Okay, so the first term, they gave us term 1, 2, 3, 4. All right, how many blocks are in the first term? Well, that looks like there's 2. How many blocks are in here? 4, 5, 6 in the second term. 2, 4, 6, 8, 9, 10 in the third term. What's going on here? Well, so 1, 2, 3, 4 by 3 is 12, 13, 14 here. Okay. So this is really, this blue table here is just this block organized, or the number of blocks organized for me. I need to figure out though, well, if I look at my answer choice, it looks like there's a recursive pattern here, but those look like, I think those are in y equals mx plus b form, aren't they? They're not recursive patterns. So in order to have a recursive pattern, I need to know the before, now, next. But in order to write out an equation in y equals mx plus b form, don't I technically need the b or the y intercept? If I look at my table, there's no 0 term. So can we put it in there? Can we follow the pattern backwards and create this kind of fake term? Or, I don't know, how could we do this? Well, let's see if we can establish a pattern. How could I go from 2 to 6? Well, it appears I added 4. Is that true to get from 6 to 10? Cool. How about from 10 to 14? Oh my goodness, oh my goodness. So how can I go? What number did I start with? I added 4 onto it to get 2. Well, if I add 4 this way, I guess I could just subtract 4 going in the opposite way. So 2 minus 4 would give me negative 2. Well, what do you know? My y-intercept is negative 2, which doesn't look like that's the case here. That's a 4. So right away, table 3 is looking pretty good, but I'm not totally sure of the slope. The change in the y divided by the change in the x is 4 divided by, well, I never figured that out, so let's go for it. 0 to 1, 1 to 2, 2 to 3, 3 to 4. Hey, what am I doing every single time? I'm just adding 1. So 4 over 1, dun, 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 is just 4, which is my slope here. That rule works. I was able to get rid of number 1 because of my y-intercept, and my slope is 1 here. So that's definitely, it's like double wrong. Okay, let's look at this recursive pattern. What does this mean? Well, this means a sub 1 equals 2. The first term is 2. Is that true? Is the first term 2? Why, yes, it is. So the first term is 2. So that part there is correct. We like that. Okay, let's look at this before, now, next rule. Let's write this out. I'll do that right under. So the now is equal to the before plus 4. Now is equal to the before plus 4. So to get to the now, look before and add 4. Yep. To get to this now, I look to the before and add 4. Yep. This is working out as well. So what formulas? We would say formulas 2 and 3. Moving on to exercise 4, it's talking about Josie, and she's collecting donations for a walkathon. And it looks like her donors pledge a certain amount up front. Okay, so they'll spend a little bit of money up front, and then the more she walks, the more money that she's going to get. All right, so down below, her donors provide her with these equations, and it looks like we need to identify some important information, like fill in the table, the pledge per mile, and then the initial donation. So the initial donation, I don't see in this table. Initial always is 0 when x is equal to 0, I guess. So I think I might need to add that into my table. All right, this isn't a problem. A is just a linear equation. So if I put in 0, well, that's easy. That's just my y-intercept. That's -2. Okay, how about when I put in 1? 4 times 1 is 4, minus 2 is 2. Let's do this for putting in 2. So if I put in 2, 4 times 2 is 8, minus 2 is 6. 4 times 3 is 12, minus 2 is 10. 4 times 4 is 16, minus 2 is 14. Then lastly, let's input 5. 4 times 5 is 20, minus 2 is 18. So how did I go? What is my pattern here? It looks like I am adding 4 each time. Yeah, definitely adding 4 every single mile. So my initial donation, that's when x is equal to 0. Oh, that's kind of weird. That's -2. We'll talk about that in a little bit. So my initial donation is -2, and what is the pledge per mile? Well, this looks like it's my slope. So I'm adding $4 per mile. Okay, let's go on to the next rule. So this person here, whoa. Okay, it looks kind of crazy at first. The initial donation, looks like we need to find that again when x is equal to 0, or in this case, our x is n. So regardless, it's this point here in the table. And what did they give us? Well, they gave us a recursive pattern, didn't they? Look at this big old mess. So let's rewrite this. So the next is going to equal the now plus 3. Okay, but my first mile is $5. Okay, so my first mile is $5. Let's put that in the table and generate the rest. To get to generate the next. So to get to my next value, I look at the now and add 3. So 5 plus 3 would give me 8. Add 3 again, I get 11. Add 3 again, I get 14. And again, I get 17. So since I am adding 3 every single time going in this direction of my table, I need to figure out this initial donation still. So let's go backwards by subtracting 3. 5 minus 3 is 2. So my initial donation is $2 in this table. And the pledge per mile, so how much did I get, or how much did she get every mile? Well, she got $3. Okay. Lastly, part C. This is a weird rule, but it's still a rule nonetheless. It doesn't look like a recursive pattern to me like in B, because I don't see any of like the n plus 1 or a sub n minus 1 stuff anywhere. Let's distribute this 3 into the n and minus 1. So what does this equal? 4 plus 3n minus 3. I can group together. Okay, I'm liking this. I can group together the 4 and the minus 3. So that's my a sub n. So a sub n is actually equal to 4 minus 3 is 1 plus 3n, or 3n plus 1, however you want to look at it. Let's see if we did this right. I like this so much better. So let's put in 1. I input 1. 3 times 1 is 3, plus 1 is 4. Perfect. Let's put 2 in. 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9, plus 1, which is 10. 3 times 4 is 12, plus 1, which is 13. And lastly, 3 times 5 is 15, plus 1 is 16. So what is going on with this table? How much are we earning per mile? Well, looks like I shouldn't say we. I think it's Josie, is that her name? So Josie is earning $3 per mile, but we never figured out the initial donation, so let's find that again. I need to go backwards in my table, so I need to subtract 3 here. 4 minus 3 is 1, so $1. Okay, so now we've looked at these 3 plans. It says, are any of them unrealistic? Well, they started off with $1, made $3 per mile. That seems pretty fair. Started with $2, then earned $3 per mile. Also pretty fair. Started with negative $2? What? You're not going to owe anyone money. So I think that we want to type in, or write down for part D, are any of the plans from A through C unrealistic? Well, yeah, the first plan, Plan A, is not realistic because we don't want to have a negative initial donation.